Hello and welcome to Meta-Evidence Articles, where we encourage community research and education with weekly articles. I'm your host, Menton Loeyball, and this week we are talking about the history of the flu. What happened after World War I? World War Flu! Spring 1918. Germany begins its spring offensive in the final year of the First World War, a conflict that would kill 15 to 22 million people. Although this conflict dominated headlines in the U.S. and Allied countries, Madrid's ABC newspaper in neutral Spain reported an even deadlier crisis, the flu. Today, Americans mostly think of the flu as an annoying, mild illness that takes you and the kids out of work and school for a few days. In reality, the flu is still among the deadliest and most widespread epidemics, killing 28,000 to over 100,000 children under 5 each year around the world. Before the introduction of widespread flu vaccines, the flu was a major cause of death and disease. The first historic pandemic attributed to the flu is sometimes claimed to have occurred in Greece around 2,400 years ago. Several hundred years ago, an outbreak in Italy earned the disease the name influenza, the Italian word for influence. Influenza became the name of the flu in English, and this disease set in among people and became an epidemic, from the Greek roots epi, meaning upon, and demos, meaning the people. Periodic heavy outbreaks spread every 10 to 40 years among a lot of people in pandemics, from the Latin pan, meaning all, and demos, meaning the people. In 1889, a well-documented epidemic of flu spread more rapidly than ever before along new transportation systems like steamships and railroads, and causing around 1 million deaths, a huge number at the time. This pales in comparison to the flu that was reported in Madrid in May 1918. The disease originated outside Spain, but other countries were heavily suppressing reports to keep morale high during the war. Spain, being neutral, had no similar restrictions and freely reported on the disease, which was infecting everyone from peasants to cabinet members to even King Alfonso XIII. Influenza deaths were somewhat milder in Spain compared to other countries, but they were reporting the highest numbers since everyone else was censoring information, and the outbreak became known as the Spanish flu. The medical response was poor, owing to a general misunderstanding of what causes the disease. They thought it was a bacteria, not a virus, and a lack of doctors, many of whom were busy treating the war wounded. All told, the Spanish flu of 1918 infected around half the global population and killed an estimated 40 to 50 million people, or 2 to 3 times as many as died in World War I. Since 1918, there have been a few other notable pandemics of flu, including the 1957 Asian flu, 1968 Hong Kong flu, 1977 Russian flu, and 2009 swine flu. In addition to pandemics, most countries also experience seasonal flu epidemics almost every year. This is in spite of great advances in understanding, medicine, and vaccines. So what gives? What is it about the flu that makes it so hard to defeat, and what's being done about it? The flu is caused by a variant of the influenza virus. There are 4 major families of influenza viruses labeled A, B, C, and D. Types A and B cause seasonal epidemics, and Type A has the highest potential for becoming a full-fledged pandemic. Genetically, the virus has single-stranded RNA, which can't be corrected for errors as it replicates, making it highly vulnerable to genetic drift, where small changes accumulate to make distinct strains. This code is made of 8 genes, which code for 11 proteins, and 2 of these proteins, hemagglutinin and neuraminidase, or H and N, sit on the surface of an influenza virus and enable the virus to enter our cells to reproduce and exit it to infect others. Since these proteins are on the outside of the virus particle, they are the parts most critical for immune response and vaccine targets. Unfortunately, the high variability of hemagglutinin and neuraminidase proteins means immunity from infection or vaccine doesn't last very long, hence the yearly flu season. Even worse, if multiple strains of influenza infect an animal or person at the same time, the viruses may combine into a new, virulent, very hard-to-stop version in a rare process called genetic shift. To summarize, the flu is dangerous, contagious, has been plaguing us for hundreds or thousands of years, and constantly mutates in ways that make lasting immunity difficult. So, how can we fight it? We fight it with constant monitoring of new strains, public vaccination efforts, clinical trials searching for more effective vaccinations, and several generations of medical and scientific advancement. The World Health Organization, or WHO, uses over 100 research labs around the world to look for the most likely new epidemic strains, those with hemagglutinin and neuraminidase mutations that would make them contagious and able to evade current immunity. Once the new likely strain is determined, the public vaccination machine starts in earnest. Over the years, producing vaccines was done by using a virus strain that was associated with a mild illness, a version that was killed and unable to reproduce, or a virus that was altered to stimulate an immune response without causing illness. New methods are looking at ways to produce vaccines that don't contain any of the dangerous virus particles and instead contain the RNA code that builds hemagglutinin or neuraminidase proteins. This gives our body a fighting chance to produce antibodies for the most likely strain of influenza virus and help win the war against the flu. Thanks for joining us on this week's episode of MedEvidence Articles. If you'd like to know more, all of our descriptions are linked in the podcast description below. You can also visit our website at medevidence.com. MedEvidence helps answer the question of who can you trust for medical information. The MedEvidence platform provides valuable information about many medical issues and the insights of evidence-based medicine. MedEvidence educates audiences through engaging and entertaining magazines, podcasts, videos, articles, and presentations. We strive to bring together diverse voices of top-level medical professionals, researchers, and experts to provide unique and engaging content that uncovers the truth behind the data. For more great content, including discussions by physicians and subject matter experts, check out the MedEvidence podcast. My name is Benton, and we'll see you next week.